Olá, esta é a série Tecnologias e Qualidade de Áudio do FM ao Podcast, da trilha 7 Rádio do 7 Experience Academy. Neste módulo, o tema é o processamento de áudio para a transmissão pelo ar e online. E para falar sobre isso, convidamos e temos muito prazer em receber Bob Orban, que todos conhecemos como fundador da Orban Labs. Convidamos também e temos igualmente muito prazer em receber o José Cláudio Barbedo, Formiga, consultor e gerente técnico da Smart Audio Systems. E agora você acompanha esta verdadeira masterclass com Bob Orban, dividida em episódios aqui no 7 Experience Academy.
Turma da 7, prazer estar com vocês. Mais prazer ainda em já estar introduzindo uma pessoa que não necessita introdução, porque ela é sinônimo de áudio de boa qualidade. Mr. Robert Orban, porque aqui no Brasil a gente pergunta qual processador que você tem. Quando o camarada diz, eu tenho um Orban, a gente já sabe que o áudio dele vai ser de boa qualidade. Mr. Orban, conseguiu fazer com que se esquecesse os modelos dos processadores. Eu não sei os modelos, eu sei as marcas, eu não sei que ele é um Optimod, eu sei que ele é um Orban, e se ele é um Orban, é bom. Welcome, Mr. Orban, greetings from Brazil.
Oh, thank you.
Mr. Orban, let me tell you a small story. My first Optimod was AT100 back in the 80s. When I put the equipment on the air, it was gorgeous. At that time, we played music using cart machines, extracting from vinyl records, and doing the recording music by music, and receiving the advertising in small reel tapes, 7.5-inch speed. And the sound of the Orban was beautiful. Nowadays, we have all in digital. A digital Optimod, my audio arriving in files, digital by MP3, by AAC. I rip music from CDs or from the internet using iTunes. And with all that digital, beautiful, contemporary upgrade, the sound of my radio sounds squashed because of the sources. The CDs are recorded with an extreme high level. The advertising arrives in MP3. So the question is, how to have a very good sounding radio station in the digital age when the sources are bad?
I think that the obvious question is to seek out better sources. MP3 has been a real problem for radio. One reason why MP3 is a problem is that it uses a psychoacoustic masking model that assumes that the frequency response between the decoder of the MP3 and the listener's ears is basically flat. Mm-hmm. So once you run that through multiband compression, where you're changing the frequency balance, that gives the danger of unmasking the quantization distortion that the MP3 algorithm is trying to hide. So we strongly advise using uncompressed sources. I think that 16-bit 44.1 is fine for radio, but if you can get 24 bits at 44.1 or better yet at 96, that will help, but the 96 really doesn't matter that much because of the frequency response limitations in the radio transmission channel itself. So I think that one of the big problems has just been the interaction of the codecs that you use for the sources like MP3. AAC is much better than MP3. So if you have to use something that's compressed, definitely AAC, and AAC at the highest bit rate that you can get. By the time you're at 256 kilobits per second with AAC, then you really do have good quality. Anyway, with the low cost of hard drives these days, there's really no excuse in the playout system for not just storing the uncompressed music instead of using compression. And the best favor that radio stations could do for themselves is to replace any older MP3 files, particularly, with good uncompressed WAV files of the same material.
Let me present you with another problem. Is that the WAV files ripped from a CD or downloaded by the internet, the producers today, they like very much to use all the bits. So they hard compress, digital limit. In the end, you have a black shadow of I call a dark audio. There is any way that loudness war, that stupid loudness war ends and we start getting good audio with good dynamics again?
I have been very frustrated by the loss of quality in modern digital files due to overuse of peak limiting in mastering. Once you try to set a target loudness of more than, say, -8 or -7 LUFS, you're going to have something that is pretty much a newly mown lawn as far as the waveform goes. One thing, at least if you're broadcasting older material, is actually to go back and seek out the original recordings,
Yes.
many of which were produced with much less peak limiting and therefore much higher quality. Unfortunately, there isn't an awful lot you can do about today's hypercompressed material. Some people have touted the use of declippers. I've tested many different declipper algorithms, and the problem is that if all you're doing in mastering is just simple clipping, just sawing off the tops of the waveforms, then sometimes declippers can make good guesses and put some of that stuff back. But more often than not, the peak limiters actually have side chains and memory as opposed to just being simple clippers. And in that case, a declipper can't possibly know what the original peak limiter was doing. Declipping itself is a nonlinear process, meaning that it actually adds new frequencies, distortion frequencies, to the program material. So declippers can sometimes actually make the distortion worse and not better.
Ooh.
So for that reason, it's very important when you try using a declipper that it be auditioned in your production studio. I think it's very risky to put declippers just on the air in part of a air chain and let them operate all the time, because then sometimes they'll help, but sometimes they'll really make things worse.
I don't know if Jesus that I will tell happens in the United States, but here in Brazil is usual. The program director wants to play a new music. Okay, he buy from iTunes or go to YouTube, open the file in his computer, look to the file, listen to the file in small speakers from the computer. And he does the addition of the music and send it to the air without having any quality control in a good monitor of the quality of the sound. Is that possible to find how good is the quality of a source of your music only looking to a graphic?
You know, I don't think you can do that very well. If you look at a graph in an audio editor and you can see that it is extremely peak limited, then chances are that the sound is not going to be good. But one consideration is that the quality of different peak limiters varies greatly depending on which algorithm you use and which manufacturer. I designed a piece of software called Optimod PCN 1600, and one of the intentions of that software is for use in mastering. That has a peak limiter based on our MX technology that we originally introduced for the 8600 Optimod FM. So it can produce very loud masters that aren't as distorted as other masters might be at the same loudness. But once again, you can't tell that just by looking at a graph. You really have to listen. And even if you're just auditioning in a computer, there's no good reason not to plug a pair of good headphones into the computer and not rely on the built-in speakers, which are basically useless. Another problem with computer audio is that many computers actually have a built-in compressor applied to particularly the speakers. So if you're going to rely on a computer for audition, you actually have to go in and make sure that the compressor is defeated. Sometimes this is not at all easy to figure out or how to do. In Windows, you have to go into the sound control panel and then look at the properties of the individual sound device that you're using to feed the headphones and turn off all the enhancements. I know that we had some issues with some Dell computers that we were using for demonstrations at an NAB one year. I was, listening to the output and I was thinking, oh boy, this sounds really terrible. What's going on here? I hear another compressor and it's pumping. And it turned out that the Dell was not passing the output of our Optimod, but was actually adding another layer of compression on top of it and wasn't doing it very well at all.
Wow. And I'm speaking about some particularities that I think maybe will only happen in Brazil. But I have a beautiful processor. All my sources are okay, good. Then the owner of the station wants my station to be louder and louder and louder. I call it the wheel driver syndrome, because he picks his car, starts to drive and starts comparing stations. Oh, my station is a little not so loud. Okay, he phones his radio and he tells the technician, I want to be louder. Then the other guy in another station, in another car, see that his concurrent now is louder, and he calls the station and say, okay, I want to be louder. And now in Brazil we have some cities where you can find peaks at 150, 160, medium of modulation of 120. May you please explain how bad is to overmodulate in the FM for the owner of the radio stations?
Well, one of the reasons why overmodulation is really bad is that there are many car radios that are designed with the assumption that the modulation will be limited to a deviation of 75 kilohertz. And the intermediate frequency amplifiers don't have much bandwidth beyond that. So the radio will start to actually clip the modulation, and it will add additional distortion that you don't hear from your off-the-air monitor. The owner will not know that this is happening unless, say, the radio in his car happens to have this particular problem. In particular, the owner will not know that this is happening with many of his listeners, and that the distortion can be bad enough to really induce listeners to just tune away because the sound is too distorted or fatiguing or annoying. So the radios are not designed for the overmodulation. So in addition to the problem of interference with adjacent stations, you also damage your own signal.
Do you believe that a big number of stations in Brazil don't have a modulation monitor? And when we ask why we don't have a modulation monitor, he says, no, it's only by law, it's not necessary. I would not know how to adjust not only Orban, but any processor without a modulation monitor.
Well, if you can gain access to a radio frequency generator that makes a reference FM signal with a known deviation, in other words, something you can calibrate a tuner to, you can actually improvise a modulation monitor with a good tuner. You can you can even digitize its output and put it in your computer and run something like the free Orban loudness meter, which has a peak reading meter in it. So if you can calibrate the tuner so that you know how big the output is when you have 75 kilohertz deviation, and you can hook that up to a peak reading meter, then you can have a modulation monitor at fairly low cost that is still good enough to prevent this problem with distorting the radios that I was talking about.
Continuamos no próximo episódio.